Welcome! Happy to have you here to a new video of the series SAP EWM Meets Automation. As a series where I try to uncover and explain topics in and around SAP EWM MFS. My name is still Hendrik, and today we are looking into the topic simulation and/or emulation. So it is all about working in automated environments but without physical subsystems. Before we look into the agenda, I would like to start with some kind of introduction and first of all answer the question, what do we have in SAP EWM Standard? It is a simulation or is it an emulation? So I was trying to find a matching definition because first of all the textbook definitions of simulation and emulation are not that simple and it's not that easy to separate those two terms, and it's even more difficult to do that in the context of the SAP EWM Standard simulation or emulation. So what I found to be useful were those characteristics. On the left side you see characteristics of the simulation, on the right side of the emulation. And if we start at the top, simulation, the term itself comes from simulus, which is like, and suggests a deeper congruence, something which is really like the thing of the real world. Whereas emulation comes from imitating and is rather an image, so it's a surface level resemblance of the real world. So with the simulation, the focus is on modeling the components of the system, where with the emulation, the focus is on recreating the behavior. And we don't care of how the components that we are modeling or the system that we are modeling is working from the inside out. We just care about the behavior. Simulation is used when we want to care and want to figure out something about how it does what it does. And with the emulation, we want to know what it does. We don't care about the rest of it. So the emulation is used when we can't use the real thing, whereas the simulation is used when we can't use it, but also want to find something out about it. So if we apply this now to what SAP EWM offers in the standard, I do think that we are actually talking about an emulation here. We can't use it to figure out anything about the real thing because it's purely sitting in EWM ABAP coding. And we want to use it to emulate what the subsystem does. And we don't want to use it to figure out how it does it. And we are focusing on the behavior and not on the functionality of the components we are modeling itself. So my interpretation is that SAP Standard offers an emulation, although you will see that later the objects and, for instance, the function module which is executing the emulation is rather called a simulation function module. So I don't know why SAP calls this function module simulation, but my interpretation for now, and that's also the term I will stick to for the rest of this video, is that we are talking about an emulation here. So what is the agenda for the rest of the video? I will start with purpose and use cases. So I will explain where the standard is useful and where it is not useful. Then I will describe on a high level how the emulation works in the context of EWM. So explain where it is being applied and how the process flows on a high level before I go into detail with, first of all, the configuration, so what do you need to do in order to use it, and secondly, a code review so that you really understand in detail how it works. So with the objective that at the end of the video, you know where you should and can use it, and you also understand how it works. So let's start with the first point, the purpose and the use cases. So what can the EWM standard emulation do for us, and especially what can it not do? Where should you take additional options, tools, etc. for testing. So it is indeed very useful if you, for instance, want to test your routing, which is usually based on the layout-oriented storage control or based on the case conveyor routing. But you want to validate your customizing, and you might have a network with multiple different routes and directions. And without an emulation in place, you would need to confirm every subtask manually. You might have a starting point in the inbound area or at the handover to the conveyor or whatever, and up until the final put away, it's like 5 to 10 intermediate tasks. And having an emulation in place which automatically confirms the intermediate tasks, that means you only have to create the first one, trigger the first movement, and the system automatically confirms all intermediate tasks for your routes. And this way you can easily, within a very short time frame, test all possible routes for your MFS network. A second point, which I think is very useful here, is to validate the format and the content of the outgoing telegrams. So usually when you start an MFS project, you sit together with your subsystem vendor and specify the interface. So you agree on a format and on the content of the telegrams that are being exchanged between EWM and the subsystem. And using the emulation, you can create all kind of outgoing telegrams based on your EWM MFS coding, and then compare the content and the structure and the format with what you agreed on in the specification, and you're already pretty sure whether you meet the requirements or not. Third point, which is one where the emulation can help, is the processing of incoming telegrams. So you can validate the code that you implemented to process telegrams which are coming from the subsystem to EWM. And for instance, you agreed in the specification phase with your subsystem vendor that these set or list of error scenarios or error codes could be sent from the subsystem to EWM. And then with the emulation, you can easily create incoming telegrams with all of those error codes and then process those telegrams within EWM with the same coding that would later be used when telegrams are coming from the real subsystem. So this is an option to easily create hundreds of telegrams with multiple different types of content, and then check how your coding behaves that processes these on the EWM receiving side. So now coming to the let's say negative parts, or where it is not useful, and that's kind of obvious, that the communication layer itself, so the physical connection between EWM and the subsystem, and along with this protocol, handshake mechanisms, all this stuff, cannot be validated. So it's not a replacement of testing a connection to a real subsystem as such. So the communication layer is something you need to plan for as a separate accurate test with a real subsystem. And most importantly, you need to be aware that the subsystem, that's the second point here, has also a complex set of code and configuration which is sitting in the PLC memory. So when you send a telegram to the subsystem, it's not like obviously activating this motor or this sensor. There's complex logic sitting on the PLC. There is coding in the same way as there's coding in EWM. There are a lot of configurations, and you're skipping all this stuff when you're simply testing with the emulation in EWM. The emulation, I will come to that later, simply assumes everything is fine, or just gives you the answer that you expect. But it does not validate any single line of code on the subsystem. That's also obvious, but I would really recommend to plan a lot of time for testing with the real subsystem in addition to using the emulation, no matter how complex or non-complex your MFS project is. Yeah. Okay, let's come to the let's say more interesting part of this video, where we look on how the standard emulation works. And I will start with a high-level view and explain at first where we have the spot and the context of the emulation. We'll start with a real-world example with a real subsystem. I took the I point where the communication starts on the subsystem level. It could also be that the communication starts on EWM side, which is the case, for example, when EWM tells the subsystem to retrieve an HU from an ASRS, and then the crane picks up the HU and sends it to the outfeed. In this example here, the communication starts on the subsystem level. So we have a physical movement, sensors and actors and motors doing something and sending signals to the PLC. And as I said, in the PLC memory, there's some logic sitting, processing the data, and in specific cases, then sends a telegram to EWM. In the example with the I point, there is data coming from profile checks and height checks and weight checks and pallet checks and all this stuff. The PLC puts it into a telegram and sends it to EWM. And then EWM processes the data, again, triggers some follow-up actions, and among some other things, maybe creates a warehouse task to move the HU further. And for this warehouse task, also sends a telegram to the subsystem. The PLC processes it in the memory, and then again sends signals to the physical sensors, motors, actors, whatever, that initiate a physical movement again. That's the high-level steps of a system without an emulation, but rather a real subsystem. If you want to get more details about the I point processing as such, there's another video I will link here, but this is not in scope for this video here. The only thing I wanted to show you here is the high-level communication flow between the PLC and EWM. So looking at this from an even more simplified perspective, EWM is sending a telegram. This is done with this function module here. The PLC receives the telegram, does whatever needs to be done, and sends a response telegram back to EWM, where the response is received with function module MFS_receive2. It could also be that the PLC starts the communication, so PLC at first sends a telegram to EWM, where it is received in this function module, and as a response, EWM sends a telegram to the PLC. So this is a cycle. It can start at both sides. Now, with an emulation in place, the right side here is skipped. And EWM does this cycle with itself. So instead of sending the telegram to the PLC, it now sends a telegram to the function module SAP MFS_sim_receive. So this function module receives the same data that usually the PLC would receive. And this function module is the one that creates a telegram as a response and sends this telegram to EWM and calls the same function module which would usually be called in case the telegram would come from the real subsystem. If you understood this concept, you already understood 95% of the EWM standard emulation. So if that's enough for you, you can stop this video now and subscribe to the channel, of course, and go back and do something else. And if you want to get more details, just stay with me. I will be going into the configuration and the details of the code of this function module now. First step, configuration, very easy, only one slide, because the only thing you need to do is change the application data of the PLC. And the PLC that you are using and that you want to emulate now as a field here as sending function module. And in this field, you maintain the function module, which is called when a telegram is sent to the PLC. And here you maintain MFS_sim_receive, the one function module that I showed you on the previous slide, which is responsible to receive the telegram instead of the subsystem. That's it in terms of configuration, really simple. No customizing needed, no complex tables to be filled, just this one function module to be maintained in the application data of the PLC. Next and last part of this video, code review of this function module. So how is the standard emulation implemented technically? It all starts with an overview of the importing parameters of the function module. And as I said at the beginning, here the short text, the description of the function module says it simulated receipt processing of telegrams. And that's why I was confused at the beginning. As I said, my interpretation is an emulation here. And the most important thing, and if you understood the flowchart that I showed a couple of minutes ago, you will also understand why this function module is importing a telegram here. So it's importing the telegram which is sent out of EWM. So in this context, it's not sent out of EWM because we are not talking to an external system. We stay within EWM, but still we are handing over the outgoing telegram to this function module as an import. So we replace the subsystem as a receiver here. And the function module starts with reading the PLC and the channel data. This is needed for further processing here. And then it moves this telegram into the SAP generic structure. This is this MFS teletotal structure. I mentioned this in multiple other videos already. The structure has all fields of all telegram types, and it's used in EWM MFS whenever you process incoming or outgoing telegrams, just to simplify the coding from technical perspective. So multiple different telegram types can reuse the same coding by using this generic structure with all fields. And based on the telegram fields, telegram type, some fields are used and others are not used. This is just preparation. And then the first interesting step is the acknowledgement telegram. So this emulation function model creates an acknowledgement telegram based on the handshake mode settings of the communication channel. So if the handshake is active, if communication channel expects for every telegram which is sent an acknowledgement from the subsystem, from the receiver, just as a confirmation that the telegram has been received and that I can send new additional telegrams. If this is the case, then here the sim_receive function module calls MFS tele_ack, and this function module will then send an acknowledgement telegram to EWM in the same way as a real subsystem would send an acknowledgement telegram to EWM. Next step, and this is the core logic of this standard emulation function module, is the determination of the telegram category for the response. And this is pretty simple. Here, if you understand this case statement, you understand the whole logic. So this basically says, in case the telegram category of the outgoing telegram is A, then the telegram category of the incoming telegram, so the one that the emulation function module creates, then that should be B. So one practical example here on the right side. When the telegram category of the outgoing telegram is a warehouse task, then the category of the incoming telegram, the one that we are building right now, is a task confirmation. Pretty easy. In the same way here on the left side you see if it's a synchronization request, then the answer is the synchronization. If it's a status request, the answer is the status message. And if it's a warehouse task cancellation, for instance, then the answer is the cancellation confirmation. And here you see a screenshot with all the options that the standard offers here. Basically the ones that I just mentioned. Here on the right side you have the value range for the categories. So this is basically behind those constants that you see here. So there's a kind of limited range of telegram types here. I will come to this at the very end of the video again. You might want to use this as a copy template for your project and then add to this case statements, whatever categories you might use in your projects. So having determined the category of the response telegram, we now derive the type from the category. So there's a difference between telegram category and telegram type. The type is rather a more granular level, and we now determine the type from the category. And this is done with either function module MFS build telegram or TEMFS Tele2 read single. The first one I think is only used for the synchronization telegram category, and for all the others we are using the second one here. So some additional steps before the telegram that we want to build is completely built and can be sent back to EWM. I didn't take screenshots of every single step here, but we are basically updating, we are determining the sequence number for the telegram which we want to build. Then we set the sender and receiver, so we are basically switching sender and receiver based on the telegram that EWM sent to the emulation function module. And then we move the telegram data back from the generic structure into the telegram type specific structure. Yeah, remember we determined the telegram type on the previous slide. And then if needed, based on the communication channel customizing, we might add some filler characters also before we start really sending the telegram. The latter is happening here. So the emulation function module calls function module MFS sim send, and within this function module the only thing we are doing is wait a couple of seconds. Yeah, by default it's 3 seconds, just to at least model some kind of external system behavior. So we wait for 3 seconds for the response, and then we call function module SCWM MFS receive. And for those of you who are following this video series here already know this is the standard function module in EWM MFS, which is used to process any kind of incoming telegrams. So we see here that the emulation is creating a telegram as a response to the outgoing telegram, and this telegram is then directly handed over to the inbound, to the function module which is processing inbound telegrams in EWM, the same way as the telegram would come from the real subsystem. So sending from the emulation perspective means receiving from EWM MFS perspective. Yeah, and that's the most important thing to understand here. I have another graphic that shows, ignore these steps here. I took this graphic from the video about the identification point. Only look at step 1. And step 1 is telegram receiving in the EWM inbound buffer, and the sub-steps of this step 1 is first of all data being received via ABAP push channel or TCP/IP RFC converter into EWM, and this step is replaced now with the emulation function module. And from here onwards, we are always calling the MFS receive to function module. So no matter whether the stuff is coming from real subsystem, so the stuff which is crossed out here, or whether it's coming from the emulation, we are calling this receive to function module, which stores the data in the inbound buffer table MFS telequeue, and from here telegram is being processed by function module MFS process telequeue. But from here onwards, everything is exactly the same, no matter whether the emulation called MFS receive to or whether the subsystem called this function module. Yeah, and that's basically it from technical perspective. I think it's not too complex, but if you never touched it, it's difficult to understand. But I hope that based on this video, it was kind of easy to understand. And if you want to get more details about the steps of processing incoming telegrams, I would recommend the iPoint blog and video. I will link it here in the top and in the video description. But for now, let us just make a quick summary and then close this video here. So what did we do? Right at the beginning, I separated the terms simulation and emulation. I showed you some definitions that I found to be useful, and I stated already that my interpretation of what we have in EWM standard is an emulation. Then I told you where it is useful, this standard emulation, and there were 3 main points. So the test of the MFS routing that you set up and the customizing, the test of the telegram creation, so the check of the content and the format of your outgoing telegrams, and then the code which is processing the incoming telegrams. That's pretty useful here, as you can test multiple different scenarios and validate your coding on the inbound side. It's not useful to test the physical connection, so there always need to be enough time to test the connection between the real subsystem and EWM. The communication, the protocol, handshake mechanisms, all this stuff. And it's also not useful to validate the coding on the subsystem, which should not be underestimated. It can be as complex as the coding on EWM side, so plan enough time for that test with the physical subsystem. In terms of configuration, there's not much to do, only PLC application data. And in terms of technical implementation of the EWM standard, it's mainly function module MFS sim receive, which takes the outgoing telegram, determines the type of the incoming telegram, so converts it into an incoming telegram, and simply calls MFS receive to in the same way as if the telegram would come from a real subsystem. And in terms of telegram content, it does not really change much. Yeah? It just keeps the header and the content, changes the type, and the response acts as a confirmation. So as a status request, it sends a status message, and for a warehouse task, it sends a warehouse task confirmation, and so on and so on. Good. Some closing words to finish this video. SAP does indeed offer a simple small tool here, but do not expect that this will cover your MFS projects. No matter whether they are low or high complex, you will for sure need to make some adjustments here based on the interface requirements and specifics of what your subsystem vendor brings into the project. But I think this function module is a good copy template, so you can copy from here and enhance based on your project specific requirements. With those words, I would like to close this video. I would like to thank you for your time. I would be grateful if you share this video, and especially if you subscribe to the channel, as that's my main motivation here. The more subscribers I get here, the more I'm motivated to proceed creating videos about SAP EWM, make it easier to understand complex processes and functionalities, and provide some stuff that help you learn about SAP EWM. Having said that, in case you need any kind of support, consulting, development around EWM MFS, your first contact should be Swisslog. I will link the website of the EWM team in the video description. Feel free to send them a note, ping them on LinkedIn, and request support for your MFS projects. Having said that, hope to see you back in the next video. That's for today. Bye and happy learning.